Page number 34. Unit 3. Humidity, condensation and precipitation. Unit structure 3.0. Objective 3.1. Introduction 3.2. Humidity 3.3. Condensation 3.4. Precipitation and its types 3.5. Precipitation and its distribution 3.6. Conclusions 3.7. Questions 3.0. Objectives: to understand humidity, its nature and its type, to study the methods used for measuring humidity, to know the process of condensation and its types, to understand the formation of clouds and its types, to study precipitation, its types and nature of distribution. 3.1. Introduction. The Earth is known as a wet planet as 71% of it consists of water, which is essential for all forms of life. Water is available on the Earth in various forms depending upon its location, position and time. The following diagram represents 3 stages of water. Water vapor. Figure 3.1. 3 forms of water. Water evaporation, water vapor, sublimation, ice sublimation, water vapor, condensation, freezing. Latent heat is required for the transformation of water from one stage to another. The heat is not recorded on the thermometer. It is required for the change of state. Example: when a decaloric of latent heat is given to ice, it melts and ice solid is converted into water liquid. Similarly, operation requires latent heat of 60 calories. The heat is released into the atmosphere at the time of condensation, which is termed as latent heat of condensation. Humidity 3.2. Humidity. Humidity is the amount of water vapor present in the air. The proportion of water vapor in the air is not the same everywhere. It varies from less than 1% to about 4% by volume. It is less in the arid regions and more in the humid regions. Water vapor is invisible. It becomes visible when water vapor is converted into water droplets of ice crystal by condensation. Types of humidity. When air contains large amount of water vapor, it is termed as humid or wet air. When the amount of water vapor present in the air is less, it is termed as dry air. Humidity can be expressed in 3 ways. They are: first, absolute humidity. It is the actual amount of water vapor present in the air. It is expressed in grams of water vapor per cubic meter of air. Absolute humidity varies with the expansion or contraction of air due to change in temperature. It is a theoretical concept and is not much used in day-to-day measurements of humidity. Second, specific humidity. It is the weight of water vapor per weight of a given mass of air. Specific humidity is usually expressed as grams of water vapor per kilogram of air. It is not affected by changes in temperature of air. It is maximum at the equator and minimum at the poles. It is more on the oceans than on land. Relative humidity. Relative humidity is the ratio between the amount of water vapor actually present in the air, absolute humidity (AH), to the amount of water vapor that air can hold at the given temperature. Saturation humidity (SH). Relative humidity is expressed in percentage. RH equals AH by SH into 100, where RH is relative humidity. AH, actual humidity, that is the amount of water vapor actually present in the air. SH Saturation humidity, that is the amount of water vapor that the air can absorb or hold at a given temperature. The capacity of air to hold moisture changes according to the change in temperature. Air can absorb and hold more water vapor when the temperature of air is more. Air is contracted when temperature is less. Therefore, less amount of water vapor is absorbed in such air. Relative humidity types of air. RH equal to 20% dry air. RH equal to 80% humid air. RH equals 100% saturated air. Wet and dry bulb thermometers, synchrometer or hygrometer, are used for the measurement of relative humidity. Measurement of relative humidity. Wet and dry bulb thermometers consist of two ordinary thermometers. The bulb of wet bulb thermometer is kept permanently moistened by a piece of muslin cloth wrapped around it and attached length of wick is stripped into a reservoir of water which is kept below the thermometer. Evaporation of water takes place from the wet muslin which covers the wet bulb thermometer. Some amount of heat will be extracted from the wet bulb thermometer. Therefore, the wet bulb thermometer always records lower temperature than the dry bulb thermometer. The rate of evaporation is related to the amount of water vapor present in the air. If the air is dry, there is a lot of space to accommodate water vapor. Hence, the rate of evaporation is rapid. More heat is extracted from the wet bulb thermometer, therefore it records much lower temperature than the dry bulb thermometer. Check your progress. 1. Define humidity. 2. Define different types of humidity. 3. How is humidity measured? 3.3 Condensation. Condensation is the process through which water vapor changes into liquid state and become tiny droplets of water or ice. Figure 9. This process is opposite to evaporation. In evaporation, water turns into vapor, gaseous form. Thus, any further cooling of the saturated air starts the process of condensation. Temperature of air decreases with increase in height from the Earth's surface. The rate of decrease in temperature with increase in height is termed as lapse rate, which is about 6.5 degrees Celsius per kilometer. With decrease in temperature, the capacity of the air to hold moisture also decreases. As a result, relative humidity increases. Air is said to be unsaturated. Air is said to be saturated when the relative humidity is 100%. At this stage, the process of condensation, conversion of water vapor into water droplets begins. The temperature at which relative humidity becomes 100% and condensation begins is termed as dew point temperature. Figure 3.2 Condensation. Water vapor, snow, water droplets. Invisible is process of condensation. Condensation is a process in which water vapor is converted into water droplets or snow ice crystals. Water vapor is in gaseous form in the air and is invisible. Is converted into liquid visible water droplets if the temperature of the air is above 0 degree, that is freezing point. If the temperature of the air is less than 0 degree, is less than freezing point, then the condensation is in a solid form as ice crystal. Latent heat of about 560 calories is released during the process of condensation. Condensation depends upon two factors: A. Relative humidity of the air. B. Degree cooling of air. Degree of cooling. A. Relative humidity of the air is less in desert region where the air is dry. Hence, greater the degree of cooling is required to start the process of condensation in these regions, where the air contains hot of water vapor. Hence, lesser degree of cooling is sufficient to start the process of condensation. B. Condensation by degree of cooling is the result of four distinct processes. First, cooling by expansion. Adiabatic process. The Earth's surface is heated due to solar radiation during daytime. Air near the Earth's surface is also heated. After sunset and sun during the night, the surface of the Earth cools down due to the terrestrial radiation. As a result, the air near the surface of the Earth is also cooled. Due to the process of condensation, the water vapor present of condensation. The water vapor present in the air near the surface of the earth is now condensed into dew, water droplets on grass blades and other low-level vegetation, or into fast small ice crystals. Second, cooling of air when it comes in contact with cold surface of land or water. Air mass is a huge mass of air having uniform characteristics, that is temperature and humidity. Condensation takes place when warm and cold air masses come in contact with each other. Boundary between warm and cold air masses is known as front. Condensation and precipitation take place at the front. Third, cooling of air due to direct outgoing radiation. Its radiation. Atmospheric pressure decreases with increase in height from sea level. In the diagram above at A, the atmospheric pressure is more as compared to that at B and at C. Imagine an air parcel moving in the upward direction from A. This air parcel will expand or increase in size as it rises to B and C positions. Temperature of the air parcel will decrease due to the expansion of air. This type of change is termed as adiabatic temperature change. The air is attracted towards the Earth's surface due to the gravitational force. The weight of the air at sea level is 1013 MB. That is average atmospheric pressure. A. Decrease in temperature due to increase in height. In this case, the parcel which is moving in the upward direction expands due to reduction in air pressure at higher elevation. Hence, the air parcel expands. Molecules of air in air parcel move further apart and temperature of the air parcel decreases to 20 degrees Celsius. This change in temperature due to reduction in pressure caused by an increase in the altitude is known as adiabatic temperature change. B. Increase in temperature due to decrease in height. The temperature of air parcel in this case is 20 degrees Celsius. This air parcel is moving in downward direction towards the its surface. The temperature of this air parcel will increase from 20 degrees Celsius to 30 degrees Celsius. This is mainly due to decrease in outside pressure. In the process of condensation, water vapor reaches some kind of surface on which it may condense. Example, dew is formed on vegetation at the ground level or on cooled metal objects. At higher elevation, such type of surface and support is provided by very small microscopic particles which are termed as aerosols or condensation nuclei. These are added to the atmosphere through various sources as ocean spray, salt particles, dust, smoke, active volcano fires, factories, etc. Raindrops may grow up to 7 mm, 7,000 microns in diameter. while drizzling droplets are less than 0.5 mm in diameter. The hygroscopic particles are much smaller, greater than 1 micron. The cloud droplets vary in size from 2 to 3 microns to 20 microns. Relative sizes of raindrop, drizzle droplet, fog droplets, cloud droplets, and condensation nuclei aerosol, these being very tiny, they are practically weightless. Therefore, clouds can remain suspended in the air. Forms of condensation. Condensation can be in liquid form, water droplets, or in solid form, ice crystals, depending on temperature of the air. Figure 9.3. Liquid form. First, liquid forms of condensation. Temperature lesser than 0 degrees Celsius. Dew, fog, mist, and clouds. Second, solid forms of condensation. Temperature increases 0 degrees Celsius. Frost, time, and clouds. Forms of condensation can also be classified as according to their place of formation. First, on the ground, dew and frost. Second, near the ground, mist, fog, and rime. Third, at higher elevation, clouds. First, on the ground, yeah, dew. It is liquid form of condensation formed on the ground, on grass blades, etc. It is formed early in the morning before sunrise when the temperature of the earth's face and the air near the surface is lowest. The dew is mostly found in the areas having temperature more than 0 degrees centigrade. The conditions necessary for the formation of the dew are sky without cloud cover, calm weather, presence of sufficient amount of water vapor in the air. Dew is very useful for plants. Desert areas have very less humidity in the air. The plants depend on dew for water. B. Frost. It is a type of condensation at the ground level. It results in the formation of solid ice crystals. Weather conditions required for the formation of frost are the same as those for dew, except that the temperature is below freezing point. At the time of condensation, if the temperature of the air is below freezing point, water vapor is directly converted from gaseous state water vapor to solid state ice crystal. Hence, the frost should not be termed as the frozen dew. Valleys are the ideal location for the formation of frost. During dry time, cold and heavy air accumulates in such locations. This air displaces warm air at the valley bottom and thus causes the inversion of temperature. Hence, the valley floors or bottoms are affected by frost, but the sides of valley remain unaffected. Therefore, human settlements are located at these areas and not at valley bottom. Frost is harmful to plants. Protection against frost is a great challenge to horticulturists in some of the temperate belt countries of the world. Various yet conservation methods are used for the protection of plants. Example, covering the plants with the paper or cloth. Second, near the ground. A. Mist and fog. These are formed near the ground. They are the forms of condensation in which many droplets of water remain suspended in the air. Mist and fog both reduce visibility. If the horizontal visibility is up to 2 km, it is termed as mist, but if the horizontal visibility is up to 1 km, it is termed as fog. Fog is denser than mist. Therefore, visibility is reduced in the case of fog. Based on the visibility, there are various types of fog. Example: moderate fog, thick fog, dense fog, very dense fog, killing fog, etc. Figure 3.3 Types of condensation. Temperature is lesser than 0 degree at higher elevation. Cloud near to the land, lower elevation, fog, mist on the land, dew. Temperature at greater than 0 degrees Celsius. At higher elevation, cloud is crystal near to the land, on the land, frost. C. Smog. Combination of smog and fog is termed as smog. Smog is also termed as piece of fog, which is more dense and dangerous. Since smog includes pollutants, smoke, etc., people suffering from chest problems such as asthma, bronchitis, etc., are more affected by smog. Visibility is greatly reduced during dense fog and smog. Therefore, it is hazardous for traffic in temperate belts. Solar rays are land, and in winter days are shorter than the nights. The pressure of excessive smoke near the ground during the smoke obstructs the solar radiation from reaching the Earth's surface. Therefore, the Earth's surface is not much heated. As a result, smoke prevails for several days. A combination of smoke and haze is termed as mist. D. Haze is the mass of very small solid particles of dust, smoke, etc., due to which the visibility is reduced below 2 km and up to minimum distance of 1 km. Check your progress. 1. What is condensation? 2. What are the processes involved in condensation? 3. Give different forms of condensation. 3. Clouds. Clouds are a condensation at the upper level. Clouds are composed of tiny water droplets of ice crystals. Clouds are basically classified according to their shapes. Two main shapes of clouds are cumulus and B stratus. Figure 9.4. Cumulus cloud stratus. Figure 3.4 Types of clouds. World Meteorological Organization (WMO) has classified the clouds into the following 10 types of as per their occurrence at specific heights. Figure 3.5. A. Upper level clouds about 6 km. A. Cirrus clouds. These upper level clouds have fibrous appearance and are white in color. Cirrocumulus. Second, cirrocumulus. These are in the form of thick white patches made up of small ripples. Third, cirrostratus. Transparent whitish clouds with air-like smooth appearance. They cover large portions of the sky and produce halo effects. V. Middle level clouds, approximately 4 km. Altocumulus. These are wide or grey rolls and rounded masses of clouds. Second, altostratus. Grayish or bluish clouds in the form of sheets or layers. They cause precipitation. C. Low level clouds below 2 km. First, cumulus. Dense with sharp outlines developing vertically in the form of rising mounds and domes. The bulging upper parts of these clouds resemble cauliflower. Second, stratus. It is a low, grey cloud cover. This layer may produce drizzle or snow. Stratocumulus. These are low, whitish or grey clouds with dark patches. 4. Cumulonimbus. The cloud with great vertical in the form of the huge tower. Upper part spreads in the shape of an uneven dome. Figure 9.5. Figure 3.5. These clouds are associated with heavy rain, thunder, lightning, hail, and tornadoes. Fifth, nimbostratus. These are the lower level clouds associated with rain, snow, or sleet. Streaks of rain or snow falling from these clouds but not reaching the ground are called virga. Cirrus. Figure 3.5 types of clouds at higher elevation. Cirrostratus, cirrocumulus, altostratus clouds, altoculumbus clouds. Figure 3.5.1 Cumulonimbus clouds. Vertical extent, strong air currents. Hail. Cumulonimbus cloud, anvil shape. Check your progress. What are clouds? Mention different types of clouds. 3.4 Precipitation. Process of precipitation. If you are doing some chemical reaction in a test tube and tiny particles are formed around it during the process of this reaction, these particles will slowly move in the downward direction and settle at the bottom of the test tube. This deposition of tiny particles in the test tube is known as precipitate. The term precipitation is used for deposition of water in either liquid, example drizzle rain, or solid, example snow hail form, which reach the earth from the atmosphere. Forms of precipitation. Precipitation can be found in liquid or in solid form or a combination of both. Measured types of precipitation are as follows. 3.6 1. Drizzle. It is a liquid form of precipitation. The size of the water droplets in drizzle is very small, less than 500 micrometers. It is often associated with fog. Second, rainfall. It is a liquid form of precipitation. The size of raindrops is larger than drizzle droplets. The size varies from 200 microns to up to 7,000 microns. Millions of cloud droplets are required to form one single raindrop. For example, a raindrop of 3 millimeters in diameter contains 27 million cloud droplets of 10 micron diameter. 3.6 drizzle and rainfall. Test tube heavy particles precipitate. Temperature greater than is lesser than 0 degrees Celsius. Cell temperature is drizzle and rainfall. Fourth, sweet is a mixture of rainfall and snowfall. If the temperature of the upper air is less than freezing point, that is greater than 0 degree Celsius, then the condensation will be in the form of lesser than 0 degrees Celsius, then the condensation will be in the form of ice crystals. Some ice crystals will be large and some will be small. If the temperature of the air at the ground level is more than 0 degrees Celsius, then these ice crystals will melt while coming downwards the Earth's surface. Small ice crystals will melt completely and will be converted into water droplets, and large ice crystals will probably melt but will remain as smaller ice crystals. Hence, the precipitation will be combination of rainfall and snowfall, which is termed as sleet. Fifth, snowfall. In the case of snowfall, temperature at the ground level and upper level is less than freezing point, lesser than 0 degrees Celsius. 6. Hail. Hail or hailstones are small balls of ice having a diameter ranging from 5 to 40 millimeter. Hailstones consist of concentric layers of ice alternating with layers of snow like onions. Hail is normally associated with cumulonimbus clouds. Due to strong vertical air currents and the raindrops are taken at higher elevation where they freeze and are converted into ice crystals. These ice crystals come down due to the Earth's gravitational force, but again they are trapped in the strong vertical air currents and move in the upward direction. More ice crystals and water droplets are added to the original ice crystals. As a result, the size of the original ice crystals increases. Ultimately, it falls on the Earth's surface where hailstones are very destructive. They can destroy crops. They are also dangerous for aircraft. Figure 3.7 Sleet, snowfall, and hail. Temperature lesser than 0 degrees Celsius. 3. Temperature greater than 0 degrees Celsius. Such land surface lesser than 0 degrees Celsius. Snowfall. Types of rainfall. The upward rising air becomes cool, its relative humidity increases and concentration begins, leading to cloud formation and subsequent rainfall. The types of rainfall are based on the method by which air is uplifted. These types of rainfall are as follows. First, convectional rainfall. Relief for relief or orographic rainfall. Third, cyclonic rainfall and frontal rainfall. First, convectional rainfall. This type of rainfall is experienced in the equatorial region. The air near the equatorial region is heated more due to high-intensity solar radiation. It expands, becomes lighter, and moves in the upward direction in the form of convectional current. The rising air cools down, relative humidity increases, and condensation begins. Clouds are formed and every day at about 4 p.m. the equatorial regions get a convectional type of rainfall. Figure 3.8 exemplifies to that there are no seasons in the equatorial region. Figure 3.8 convectional rainfall. Warm land, convectional air currents, cloud condensation rainfall. Second, relief or orographic rainfall. In this case, wind is obstructed by mountain ranges and is forced to rise up as the air rises upward. It cools. Relative humidity reaches 100%. Air is saturated and condensation begins. This causes the formation of clouds. They provide rainfall to the windward side of the mountain slope, the western side of the Western Ghats, that is, Konkan coast, receives this type of rainfall. As in this rainfall, air is lifted due to the obstruction caused by the Western Ghats. It is termed as orographic. Oro means mountains rainfall or relief rainfall. Figure 3.9 Orographic relief or relief rainfall. Sea winds goes windward side, condensation cloud stops on the mountain, rain shadow area for leeward side. When the wind bearing the wind across the mountain ranges, they become warm and expand, hence they are able to absorb more water vapor. So the clouds coming towards this region are not able to give rainfall, or very less amount of rainfall is received in the leeward side of the mountains. Therefore, it is termed as a rain shadow zone. Konkan coast, northeastern part of India, southern slopes of Himalayas, East China, Southeast United States, and East Brazil receive orographic type of rainfall. That cyclonic rainfall or frontal rainfall. Tropical cyclones develop in the tropical region. Due to cyclonic activity, air is lifted up with a great force. Condensation takes place due to cooling. As a result, clouds are formed. The region gets heavy rainfall, but it lasts only for a few hours. Figure 3.10. Tropical cyclone. Then we isobots. Strong air currents to the cloud we are rainfall. On the other hand, the frontal rainfall is experienced in the temperature regions due to the development of fronts. They are formed due to the merging of air masses having different characteristics. Air mass is a huge quantity of air with respect to temperature and humidity conditions. Thus, when the two air masses having different characteristics, cold or warm, move towards each other, they do not mix instantly, as their properties are different. The warm air mass being lighter and less dense rides over the dense cold air mass. Thus, a zone of suppression develops as a front. Warm air uplifted along the front pools and clouds are formed along the front. As a result, the region gets rainfall. This rainfall is in the form of drizzle and covers larger areas. This type of rainfall may last for many days. Figure 3.11. Figure 3.11. Temperate cyclone. Cold, colder rainfall. Warm air to the condensation cloud. Thunderstorm. Thunderstorms are different from cyclones. In the case of a cyclone, wind rotates around the center, but in a thunderstorm, the wind does not rotate. Thunderstorms are associated with strong upward moving air current, cumulonimbus clouds, lightning, and thunder with heavy rainfall. They are sometimes termed as cloudbursts. Due to intense heating of Earth's surface, very strong and hot convectional currents are generated. Cumulonimbus clouds are formed having great vertical extent. Development of static electricity, that is positive and negatively charged particles, causes flashes of lightning and thunder is produced by expansion of air due to the tremendous heat of lightning flashes. Thunderstorms are also associated with hailstorms. 3.5 Distribution of rainfall. Distribution of rainfall on the Earth is not even all over. Some regions receive rainfall throughout the year, while some regions receive it either in summer or in winter. Various factors influence the amount of rainfall received by a region. These are location, nature of relief, amount of vegetation, etc. Distribution of rain amount is as follows. A. Rainfall throughout the year. Equatorial region and areas of Western Europe influenced by western lights get rainfall throughout the year. Rainfall in the equatorial region is heavy. B. Summer rainfall. The savanna region, continental interiors, and tropical monsoon regions receive rainfall during summer. Tropical monsoon regions in India receive heavy rainfall during summer due to the southwest monsoon winds. Due to apparent change in the direction of vertical centers, southern part of the India also receive rainfall from the northeast monsoon winds during winter. Winter rainfall. The Mediterranean region is region which gets rainfall only in winter due to southward shifting of pressure and wind wales. This region is under the influence of western lights during winter, therefore it gets rainfall in winter. Distribution of the rainfall in the world. Nature. Rain. First regions of heavy rainfall is lesser than 200 equal to region, equatorial region. greater than 20. Equatorial second monsoon, the west coast of Europe and North America. Second regions of moderate rainfall, 200 to 25. Southeast Asia, China, East China, Base Brazil. Regions of rainfall scanty rainfall is lesser than 25. Tropical hot deserts, examples of second mid-latitude desert, example Gobi, Australian desert, etc. Third polar region that is cold as deserts such as Antarctica. First, check your progress. First, 1. Define precipitation. 2. What are the processes of involved in precipitation? 3. Give different forms of precipitation. 4. Why rainfall is not evenly distributed in the world. 5. Explain the follow. First, equatorial rain. Second, summer rain. Second, winter rain. Third, winter rain. 3.6 Conclusion. The amount of precipitation is in different forms that provides fresh water supply to a region is governed by various processes of humidity formation, its condensation and precipitation over the period of time. This is determined by its absolute and relative location of the nature of relief amount and vegetal amount, etc. Interference in this natural mechanism invites the natural disasters in the form of floods and or drought cyclones, etc. 3.7 Questions. Define humidity. How do you measure the different types of humidity? To define condensation. Explain the process of forms of condensation. 3. What are clouds? Give a classification of clouds. 4. What is precipitation? Why do we get variation of the type of precipitation?